Hello, welcome to AP Chemistry, and today I am doing number 35 from chapter 13. The question is, the equilibrium constant, K, is 2.4 at 10 to the third power at a certain temperature for the equation here. For which of the following sets of conditions is the system at equilibrium? For those that are not at equilibrium, in which direction will the system shift? For A, B, and C, this is the three sets of conditions that you need to see if it's at equilibrium. To do this, you should have read chapter 13 and know the three possible cases for the relationship between the reaction quotient Q and the equilibrium constant K. So first, you should write out the equilibrium expression for K, which is the concentration, the products of the concentrations of the products over the concentration of the reactants. Remember that if there's a constant in front, then that will be the power that is going to. And the only ones that can go into an equilibrium constant are gases and aqueous solutions. Solids, liquids would not be written in here. So this is the equilibrium expression, and K equals 2.4 times 10 to the third power. So for A, you will have to find the concentrations of for ones given. And then to find them, they give you the moles of NO, N2, and O2, but you need to find the concentrations for them. So the concentration will be in the molarity of them. Molarity is the number of moles over the number of liters. So they gave you the moles and the liters. And for this one, you'll get the concentration of NO is 0.024. The concentration of N2 is 2.0. And for concentration for O2 is 2.6. So you need to find Q. To find Q, you will also use the equation here, but they will be initial concentrations. So you will use a zero here to show that it is the initial concentration. Then you will put in the concentrations that you got, the initial concentrations that you got in these calculations before. And remember, do not forget the powers, or you will not get the right answer. Q equals 9 times 10 to the third. Be careful of significant figures. So since the smallest one is 2, then you should have 2 here. So okay, Q is 9.0 times 10 to the third, which is greater than K. So the system is not at equilibrium. And then since Q is greater than K, so there are more products. So since there are more products, then the system will shift left. So, and that answers to both questions. This is how you'll do for part B and part C. I will not show them here because that would be over. I don't have enough time for that. And then you should know your three cases. If Q equals K, then it's at equilibrium. If Q is less than K, the system is not at equilibrium and will shift to the right. And that's that's how you will do the problems.